All right, make sure as we go through this, if you didn't know how to do it, you write it down and you take notes because tomorrow is very similar. All right, number 1, label each table below as to whether or not each ratio is equivalent. So there's a couple of different ways to look at it. This one, it's hard to tell what the relationship is, how you would get from 3 to 4 or from 6 to 8. So you can turn them into fractions, like is 3/4, is it equivalent to 6/8? Anybody know if those are equivalent fractions? Well, how would you get from 3 to 6? Times 2. And to get from 4 to 8 is times 2. So, yes, those are equivalent. Or I could say 3/4 is 7,500, 75 cents, 6/8. If I divided that, I would get 7,500. Or the easier way to me is to cross multiply. 6 times 4 is 24. 3 times 8 is 24. So we can tell that these two are equivalent. And now I need to check and see if these bottom two are. What is 8 times 12? 96. And what is 16 times 6? You also get 96. So would we say that these are equivalent? Yes. This is what I mean by I need to see math. You can't just have a yes and no. You either need to show how the fractions are equivalent, or you need to find the unit rate, or you need to cross multiply. Yes? Right, that's what I showed right here. Okay? All right. Here, we could say 2 divided by 2 is 1. 6 divided by 2 is 3. And is 8 divided by 2 5? No, it is 4. 8 divided by 2 is 4. So are these equivalent? No. Could you also cross multiply? 6 times 1 is 6. 2 times 3 is 6. 8 times 3 is 24. And 5 times 6 is 30. So because I get a 30 here and a 24 here, that's also no. Do you see all the different ways you can solve these? All right. What about C? Are these equivalent ratios? No. 6 times 2 is 12. 4 times 4 is 16. So I can automatically see that's a no. And what about D? Are those equivalent? Okay, let's check. 2 times 5 is 10. 10 times 1 is 10. 5 times 10 is 50. And 25 times 2 is also 50. So that one is a yes. Questions? All right, let's look at number 2. It takes 2 hours to travel 30 miles by bike. How long will it take to travel 105 miles? So let's set up our first ratio. 30 miles in 2 hours equals 105 miles in how many hours? You could have had these flipped. Your hours could have been on top and your miles could have been on the bottom. That doesn't matter. Cross multiply. 2 times 105 is 210. 210 divided by 30 is 7. Is that correct? Okay. So how long will it take to travel 105 miles? It will take 7 hours to travel 105 miles. Number 3, a student gets 17 out of 20 questions correct on a test. What percentage of the questions did the student get correct? Anybody know what the grade would be if you got 17 out of 20 correct? Is it a 75? Aiden, what do you think it is? It's an 85. So there's a couple of different ways to do this. You can make it a fraction, 17 out of 20, and you can just divide. Can we see that? No. Oh, there we go. 17 divided by 20. And you get 85 hundredths. And to change that to a percent, we move this decimal 2 places to the right, and that becomes 85%. What if it asked you what percent the student got incorrect? Could you solve that with this information? What would you say the percent is that they got incorrect? 15, right? Because it's out of 100%. So if you get 85% right, you got 15% wrong, because a percent is always out of 100, correct? Okay. All right. So let's put our warm-up to the side, and we're going to need in our notes this page right here, page 66. We already glued it in at the beginning of the unit. So let's go ahead and turn to page 66, and we'll take some notes. All right. So as we talk about ratios, we're going to talk about how we can graph ratios in different relationships. So let's look at the vocabulary that we're going to need. The first thing that we're going to need to know is we're going to need to know what is an independent variable. Let me just put the old notes up here so we can look at that. All right. An independent variable is a variable whose value determines the value of the other variable. The independent variable is always your x. This is your x. Let's just read through these and then I'll let you write them. A dependent variable. A variable whose value depends upon the independent variable. This is always going to be your y. Unit rate, we already know what that is. A unit rate is a rate with a denominator of 1. And the last thing, this is what's new. The constant of proportionality. This is the same as the unit rate. It's another word for unit rate. Constant of proportionality. That's what we call it in 7th grade. This is the number that is multiplied by the x. So let's take a few minutes and let's get these vocabulary words written down. Proportional relationships can be represented on a table as an equation in a graph. So we're going to take one word problem and we're going to look at it. We're going to solve it and we're going to see what it would look like as a table, as an equation, and as a graph. This is something that you need to be able to do with every rate problem. So our example, let me switch notebooks. Olivia always charges the same rate for babysitting. On Saturday, she earned $30 in 5 hours. That's our rate. Represent the relationship as a table, equation, and a graph. So the first thing that we need to do, we need to look at our starting questions. What are the things we would ask ourselves? What are the two variables being compared? Well, we're comparing the money she earned and the hours she worked. So that's what we're going to write. Money earned and hours worked. What is the independent variable? What's the thing that can be changed? When someone calls and hires a babysitter, we're not going to change the rate. We can change how long that we hire them, right? The hours worked. So that's going to be our independent variable. That's going to decide how much money we make, how many hours we worked. That's the independent variable. And remember, our independent variable is always going to be our, as we look up here, it's going to be our X on our table. What's the dependent variable? What depends on the hours we worked? The money earned. The money that we earn depends on the number of hours that we work. What is the unit rate? How are we going to find our unit rate? We're going to take $30 in 5 hours equals how many dollars in 1 hour? And so how many dollars per hour is she making? What's 30 divided by 5? 6. So the unit rate is $6 per hour. That's the right words right there. $6 per hour is the unit rate. So we've already known how to do this. Hopefully in 6th grade you talked about independent and dependent variables. I know that we did when we were doing our warm-up reviews at the beginning of the year, but we're going to practice them some more. All right, any questions on this page before we go to the next one? All right, we're going to continue with this problem. Turn the page on 67. We're going to fill out a table. And it's the same problem. Olivia always charges the same rate for babysitting. On Saturday, she earned $30 in 5 hours. Represent the relationship as a table, equation, and a graph. So here we're going to complete a table for it. So the top row is always your X. The bottom is always your Y. Independent and dependent. And we said our independent is going to be the hours. And our dependent is going to be our money earned. So we know that we want to have 5 hours on there. So let's start at 0. 0 hours, 1 hour, 2, 3, 4, 5 hours. So is there anything that we can fill in here that we already know? Aiden, what do you think? Do what? So we know that 5 hours was $30. Does everybody see how Aiden knew that up here in the problem? 5 hours is $30. What else? Is there anything else in there we already know? If you worked 0 hours, how much money did you earn? $0. We already know that one. Did we already find the unit rate? What was the unit rate? $6 per hour. So this 1 hour, we know that that's going to be a 6. So what would 2 be? 3 is, and 4 is 24. So do you all see how we went from here to here? So a lot of times the hardest part is figuring out which is your X and which is your Y. Make sure that you label. And then I usually always start at 0, and you want to make sure that your numbers up here match your numbers in your problem. It's very flexible though. I could have done 0, 1, 5, 10, 15. So you can use numbers as long as they make sense. All right, questions? Okay, so let's look at what that would look like on a graph. Remember, on your graph down here, your bottom is your X, and your vertical is your Y. Do you remember that? So, if this is our X, what's that label? Hours. Write that down here. And if this is your Y, what's that label? Money earned. Okay, and how do we know what numbers go here and here? Well, we need to look at our table. They need to match. So here, our units down here are going to go 0, 1, 2, 3, 4, 5. So the corner is our 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everybody putting those labels? All right. Money earned. 0. What numbers go up here? 6, 12, 18. So you can use your units here to mark those. 6, 12, 18, 24, 30. I could keep going. 36, 42, 48, 54, and 60. And now can we plot those points? Yes. So the first point I'm going to plot is 0, 0. At 0 hours, we earn $0. Next, 1 hour, we earn $6. At 2 hours, we earn 12. And at 3, we earn 18. 4 is 24. 5 is 30. What do you notice about those points? They make a straight line. Any ratios that are proportional will always make a straight line. So you want to take that, and if you have something to make a straight line with, some sort of straight edge, draw a line through it, and it will continue that way. So if they are proportional, they'll make a straight line, but the other rule is they have to go through 0. Your first point always has to be 0, 0. If it was 0, 12, you would automatically know those are not proportional. Proportional relationships go through the origin, and they make a straight line. So that equation, here's what's important to know about an equation. It's always going to look like y equals a times x. Well, we see our y. Here's our y. Our y always equals a times the x. So the a is our constant of proportionality, or our unit rate. Use a highlighter. The a in that equation, the a is always the constant of proportionality, which we said is the same thing as the unit rate. So I can now write an equation to match this problem. That is y equals, what did we say our unit rate was? Where our 1 is? What's our unit rate? $6 per hour. So y equals 6 times the x. So the one thing that we had to find to be able to write an equation is you had to be able to find the unit rate. So your equation is always y equals the constant of proportionality times the x. And so if I was given a graph, could I just find the constant of proportionality on a graph without having any other information? Yes, you would always just go to the 1. You go to the 1, you go straight up to where the point is, and then you go over to the left, and there's your constant of proportionality. So on a table, here's my constant of proportionality, where the 1 is. 1 hour is $6. My constant of proportionality is here. 1 is $6. And in an equation, y equals the constant of proportionality times x. You have to be able to find that relationship in all three of those different versions of the problem. So our summary questions. Let's take a look. Use the table, graph, and equation to determine the constant of proportionality. So we've done that. Here it's 6. Here when I go to the 1 and I go over, I get 6. And in an equation, this is our constant of proportionality. So in all of those, it is a 6. And how does the constant of proportionality compare with the unit rate? What will we say? What do we know about the constant of proportionality and the unit rate? They're the same, right? They're the same thing. That's the big idea that you need to understand from this section is the constant of proportionality and the unit rate are the same number. All right, so let's switch over to page 69 and let's make the connections. Let's kind of wrap this all up into a big summary. So we're going to take what we just learned and we're going to try to make some connections here with this graph. Describe how you would find the constant proportionality in a graph. Use this graph to help you. So what we know about the constant proportionality, it is the same as the unit rate. Same as the unit rate. So what did we learn? We're going to go to the 1. We're going to take a highlighter and we're going to go straight up to where it crosses this line. And then we're going to go over to the left. What is our constant of proportionality? 8. Okay, so we can tell that from a graph. So let's write the steps. All right, your first step is to go to the 1 on the x-axis. Step 1. Step 2, go up to where it meets the straight line. Three, go to the left to find the number on the y-axis. That's all there is to finding the constant of proportionality. All right, so we've done that on a graph. Now let's look. How would you calculate the constant proportionality when given two values? So if I just had the problem, Paul earned $46 in 10 hours, how would we find the constant proportionality? Remember, we said that is the unit rate. So we're going to calculate the unit rate. So $46 in 10 hours equals how many dollars in 1 hour? So we need to divide. What are we going to divide? What do you think, Asia? Yes, 46 divided by 10. And you get 4.6. And so what is that as money? $4.60. So the equation would look like y equals 4.6 times x. That's the equation. So the constant proportionality is 4.6. So if I'm looking at different things, how can I tell if a relationship is proportional? By looking at a table, a graph, and an equation. So use your examples to help. So if I'm looking at a table, how can I tell if the relationship is proportional? So looking at this table, how can I tell if these are proportional? Well, am I multiplying each of these by the same number? So here, 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. 4 times 6 is 24. And 5 times 6 is 30. And even 0 times 6 is 0. So on a table, you can tell if each x value is multiplied by the same number. That number is the constant of proportionality. All right, how can we tell if it's proportional on a graph? Well, we already talked about that. Is if there is a straight line that passes through the origin. And remember, the origin is 0, 0. And we can tell if an equation is proportional if the equation is written as y equals a times x. Or y equals a, and sometimes you'll see the x in parentheses, but we know that's the same thing. And what is the a in that equation? The a is the constant of proportionality. All right, so I know that seems like a lot, but really when you put it into practice, it's a little bit easier to understand. So as soon as you get those notes done, we're going to look at the first problem in your packet together, that packet of papers that you picked up today. We're going to look at that first problem in your packet together. All right, so let's take a look at this first problem. So it's very similar to what we just did in our journal. Michaela babysat for 4 hours and earned $22. So our variables are the same as what we did in our notebook. It is money earned and hours worked. One of those is independent and one of those is dependent. So which one of those can you change and it makes the other number depend on it? Ava? The hours worked. You want to earn more money? You work more hours. That's the one that you can change. Hours worked. And remember, that one is the X. So that makes our dependent variable the money earned. And remember, that one's going to be your Y. Unit rate, $22 in 4 hours equals how much money in 1 hour? So let's do the math. 22 divided by 4. 5.5. So how much money does she make per hour? $5.50. So remember, on a table, this is my X, this is my Y. So hours, oops, and money. So we know we need to be able to go up to 4 hours, so we can start at 0, and we can go by ones. So at 0 hours, it's $0. We already found 1 hour. It's $5.50. We know that 4 hours is $22. How do we fill in the other numbers? How would we figure out how much 2 hours is? Aiden? Well, remember, this is a multiplication relationship. 1 times 550 is 550. 2 times 550 should be 11. 3 times 550 is at 1650. Yep. Try the last one. 5 times 550. Nope, my voice is not going to make it today. What do we get? $27.50. All right, so graph down here is hours, money, so 0, 1, 2, 3, 4, 5. It needs to match our X here. Our Y can match that. 0, 5.5, 11, 16.5, 22, 27.5. And you graph, and we know that they are proportional, so we know it's going to be a straight line. 0, make a straight line that goes through the origin. We know that they're proportional. Our equation is our Y equals our constant proportionality times the X. So Y equals, the constant proportionality is right there, 5.5 times the X. And so what is the constant of proportionality? It is 5.5. Right? Because we see that, we see it here in our unit rate. We see it here in our table. We see it here on our graph at our 1. And we see it here in our equation. So all of those things should be the same throughout. Does that make sense? All right, hold on to this paper, and we are going to work on it together in partners in class tomorrow and start packing up.